The AI loves to overcomplicate. You might ask it a simple question, it might not have all the context it needs, and suddenly it goes off on a very long tangent to get the answer at once. It doesn't realize it doesn't have it, doesn't warn you there's not enough info. It's just going to fill in its blanks. It's going to start overcomplicating its deliverable. And so it definitely tends to over engineer. You often hear these use cases that AI, when you use it for code bases, it just increases your code base size unnecessarily. Hi. In this presentation, we'll be going through some of the touch points and considerations we've identified with AI use in organizations. And we'll also be going through a high level data strategy, a high level AI strategy that you can use when you are planning your AI rollout for your organization as well. So, diving right in, when we think about AI, it's definitely here to stay. And inside of Dataracity as well, we consider AI indispensable. We use AI in a lot of processes. We use AI really to help ourselves innovate and to be effective at our jobs and deliver more value for our clients as well. We have, however, identified some areas in the organizations and in our own organization where it becomes concerning when you look at long-term AI usage and long-term unstructured AI usage. So moving into our presentation, we'll be discussing here some of the initial risks with long-term usage with AI. Now, when we think about the AI usage, all of these risks, they are already existing in many teams, many processes, especially in the BI world as well. These risks are very apparent already. You often find with teams being unstructured, with work being unstructured, ungoverned, you often find artifact sprawl, a lot of duplicated code, a lot of duplicated Excels, a lot of duplicated reports, business rules lying all over the show. This is already a very common problem in teams that we try to solve as well. You often find that when you're delivering reports, when you're delivering code work, when you're delivering various objects, a heavy process of user acceptance testings would be required. For reporting, this would be reconciliations. For Excel, you have to match existing reports. So yeah, you'll also have the same concern with teams. Sometimes you quickly push out a report, you quickly get job done, maybe you're under pressure, you don't do your due diligence, so you have this problem with reconciliations, with testing code. Also, a lot of the time, a lot of reports, a lot of Excels, a lot of manual work is involved in it, a lot of hard coded references, a lot of business rules inferred. All of that IP sits within your reporting world. Often it's very complex, very tangled, one report built on another, a lot of business rules. Maybe people forget to update things. So you sit with a lot of complexity in your environments. All of this combined means your maintenance becomes very difficult. Usually, when you're trying to change business rules, a lot of things break, a lot of your lineage dependencies also aren't clear, and some unforeseen impacts come out of this as well. So, maintenance is a big concern, and this is where we see the same concern with AI currently. AI definitely will just happily add new code, will happily add a functionality there, a functionality there, various functionalities all over. And now every team member might have their own context, their own AI that they're using. Now, all of those business rules lives within each team member. So AI has the same problem where you have many different code structures, many different objects living across many different platforms, even more so with different context windows. The AI as well has the problem with reconciliations. AI is very dependent on its context window. AI is very dependent on the type of data you give it, the type of questions you have. So it will happily say that its answer is correct, but it doesn't realize it might have less of the data. And we'll touch a lot more on the context windows further in this presentation. Also, the AI definitely likes to make complex things. It happily generates very vast sets of code really quickly, so the user might not realize just how complex the AI's answer has been or the route to getting to that answer. So a lot of complexity gets added to the environment. Another problem here is also that the AI does a lot of inferring to get to an answer, and therefore that IP linked to that AI context window is within that context. Now, as more IP starts getting hidden in the context windows, and obviously this increases your maintenance barriers. And so now when a report is deemed inaccurate or somebody realizes something wrong, a lot of effort needs to be spent to figure out which point did the AI's reasoning go off. And it's often a lot more grayer area than code or Excel. Is a lot more difficult to trace where the AI's reasoning fell flat. Now, with all of this as well, clearly AI complicates more things in this world as well. The AI loves to overcomplicate. You might ask it a simple question, it might not have all the context it needs, and suddenly it goes off on a very long tangent to get the answer at once. It doesn't realize it doesn't have it, doesn't warn you there's not enough info. It's just going to fill in its blanks. It's going to start overcomplicating its deliverable. And so it definitely tends to over-engineer. You often hear these use cases that AI, when you use it for code bases, it just increases your code base size unnecessarily. And then you have to spend a lot of man hours to reduce that code size, to optimize, to refactor. A lot of that is also involved in the BI world. A lot of objects get created, a lot of Excels might exist, a lot of overcomplication. Another big thing that AI overcomplicates is again the context window. The bigger this context window becomes, and we'll touch again on this as well, the more likely it is to hallucinate numbers. So you start having this problem that some of your numbers might seem correct, but when you actually dig into it, a lot of it doesn't seem to add up. A lot of inferred assumptions are made, and you have this concern that AI is starting to give you wrong numbers. And then what this brings is the blind trust from team members. AI seems really confident. It's really agreeable. Doesn't warn you about certain paths taken. So team members start to have blind trust in what the AI delivers. They don't really question what is how the AI got to its answers. So this is how AI can complicate life. Exposed usage. Definitely the big problem is that nobody's keeping track of the AI. Nobody's asking how it got to answers, and nobody is trying to keep things structured, make sure the right information is being fed to the AI. So in summary, in all cases, we definitely have to treat AI as a junior team member. What this means is that no matter who asks the AI, so no matter how much context you give the AI, the same with a junior team member, no matter how experienced they might be, you always, when they join the team, you have to always have oversight. You have to always treat them as a junior. You have to give them incremental information, keep it small, keep the context accurate. And when they deliver work, you definitely have to spend the time to look at it and to review, is it correct? Is it doing what it needs to? Have to review all the assumptions. So that's where senior oversight plays a role a lot. In the coding world, you would do code reviews properly. And the same thing with AI. When the AI gives you code, as much as possible, you'd have to understand what was it doing within it. You have iterative questions, interactions with the AI. Same for the BI world. For reporting, if you are generating Excels, you have to step through the Excel carefully. You can ask the AI how it got to answers as well, but AI could still infer, and that context window could be so big that it struggles to even understand how it itself got to answers. So you have to be very careful, have to treat it as a junior team member at all times. Now, when we think about how do we understand these risks, how do we understand the impact of AI, we've come up with four kind of pillars that we should consider. Obviously, security is a big concern. This context window, how much data do you need for the AI to be accurate? How do we control context? How do we make sure AI stays accurate? And this is like policing, having recon reports, all of those accuracy considerations. How do we make sure reports generated by AI are usable effectively? And then the big one is the cost. And these days, there's a lot of information going around about unexpectedly high costs associated with AI work. We'll go into how these costs come about, how to minimize them. But making sure your cost for AI usage stays low makes it more available for your general team to use, and without you worrying that you have to pay enormous sums for making AI useful. So we go into each of these four pillars, starting off with the security side of things. So here we have kind of 8 high-level security considerations. A lot of this is already understood, but the first one here, shadow AI, is where team members are using personal AI on their phones, on their personal machines. This means they're signing into their AI platforms using their personal accounts. This is obviously a big problem. We lose ability to audit, we lose ability to control what's going on. They might paste data into the personal platform, and that might go to train public models. This is a very well-known problem, a very big risk, and a lot of work has already been done to minimize this risk. But that data could still go. They might have a setting enabled they didn't realize, and they paste the data, and the setting makes sure that data is accessible outside. They might share their chat with another person. That data goes, and then maybe that person wasn't allowed to see that data. This talks to like the access gaps, compliance, yeah, personal information, like your SIN numbers or your ID numbers, those might go through. You might have shared HR data and it might have been in the context, and that HR information is shared with someone who was not supposed to know that existed. The use of AI as well. You ask it a question and you've given it access to your business environment. It can go off and access folders you didn't realize it had access to. Maybe it's a very sensitive folder in your environment. It read through it, it wanted its answer, and it found a way to give that answer to that person. And it didn't necessarily was supposed to go that route. It would have accessed information that it wasn't supposed to. These are real concerns when you are connecting your AI agents to your business environment, like your Outlook, on your Teams chats. Those environments typically is backed by SharePoint, even in the Windows world. And that SharePoint folder structure, a lot of information is shared there on OneDrive, and it's a very big exposure. So you have to be really careful around the type of access your AI can have. Now, we touched on the training exposure of the public models. A big one is also the auditing of what's happening when you are using the shadow AI, or you haven't enabled it, or you're using a third party. You're not using your Windows world. It's very difficult to know what are people actually asking, who's using it, who's accessing information, are they accessing the wrong information, are they asking sensitive questions. So that audit trail is very important. Now, the big security risk is around credentials as well, and it's a bit of a nuanced effect. When we think about agentic AI, we expect that AI to go off and do tasks for us. Now, for in many cases, those tasks would require credentials. And that's where we come in and we share our personal credentials, our enterprise credentials with the AI. It stores it in its memory, in context, it reuses it, it's available. Now, the big problem with that is definitely prompt injection. And this means that, let's say an AI goes off and it scans a website. What it does is it reads all the text of that website. And what has been proven is that if you embed a command to the AI in the text, and it could even be like, if you're an AI, do the following, uh, hackers or malicious actors would then make sure that the AI takes any credentials it has, and it writes those credentials to a server the malicious actor has access to. So this is prompt injection is very common. You have the AI scan things, you want information off of the web, and the AI is very effective at condensing and making that information usable. But there's a big risk that you've shared your credentials, and it wouldn't realize that this command is a hacking, is a prompt injection. It would happily follow the command it got instructions for. So there's another problem, like as well. Let's say your context in your chat has credentials. You could inadvertently share that context with somebody, and all of those credentials follows along. Another big risk is that the AI would hard code those credentials into code. So there, now you've got the Python notebook, you share it, you didn't realize all of your credentials are in it, at a very big risk with credentials and how AI handles it. So we have to always be careful when dealing with the AI. It has to be governed properly, and we'll get into how to govern that a bit better later on. So on to the next pillar that we have here. We have the discussion about the context. Now, context, the big concern here is how is it managed? How big must it be? And you could imagine that in your current context window, you have this long chat with your AI, and you've given it files, you've uploaded project folders, you've structured yourself, and it could be a very big context. Now, that context, obviously, the bigger it gets, the more the AI struggles to read through it. There's been a lot of studies recently where it's shown that AI pays more attention to the start of the context and the end of the context. And anything in between, it kind of struggles to remember. So as your context window grows, your AI is going to struggle to stay aligned with what you are asking it. And it can start hallucinating, and noise comes in, and it can start inferring a lot of results. We call this like drift as well. And the answers returned stops being accurate. Now, if you've been in this context a long time, you might not realize that that answer is shifting. And this is definitely a big problem as well now with skills coming in and MCP servers and making the AI more intelligent. All of those skills, all of those servers get added to this context window, and the context grows. So companies have to make sure, how do we manage our context? How do we manage our AI so that we can keep this context small and keep accurate answers? If a new person in the company comes and they ask the AI something, they might not even realize some of that answers is wrong. They might go off and make decisions on those answers because the context provided to that AI wasn't kept aligned. So very important consideration. This has a big important impact as well on cost, and we'll see that soon. But this speaks to the accuracy of a concern. Yeah, we have another example of accuracy, and this is where we touched on saying we don't necessarily know how an answer was derived. It looks accurate. We might not have realized that the AI decided to filter out information. The AI decided to ignore a section of the business to get to an answer. We might have asked it maybe utilization, maybe profit, and it gives us a very accurate looking number. But then we have to very carefully say, how accurate is it? In what situation is it? What context did the AI use to look at this information? So there's a in where we keep our context structured, where we keep relationship clean. This helps the AI stay a bit more accurate, but we never get away from needing to police the answer. And now this the big problem here is the more vague it is. Let's say it's a very vague question. You sit down, you got an idea this morning, you want to test your hypothesis. It's a naturally a vague question you ask. That vague question, the more vague it is, the less you can trust the number, the more you have to really dig into understanding what was the AI doing to get to that answer. So then another example of the accuracy problem here is, let's say the AI went and built out the automation for you. It's an agentic AI. It built an automation. It built a nice Python notebook. You just run it every day. It does what it needs to do. It looks really good. Everything looks correct. But because it might be Python, because it might be lookups, it might be Excel, it might be very complicated case statements, it starts being very difficult to see what is happening inside of it. As a programmer as well, it could be such foreign code to you that you're just kind of accepting the result. You're not really looking into what's happening. And the risk here is that if an edge case comes along, you don't realize necessarily something's broken. The AI might have added a way to handle errors. It might throw away automatically results that aren't working for it. So there's that. You might not even realize, it might not warn you it's doing that, and you don't realize something's breaking. And after a year or so of using this, somebody maybe does a reconciliation, like, oh, so in these scenarios, in the edge cases, breaking silent failures, you don't realize this is happening. And that then becomes very difficult to trace. Why is this something breaking? Why is a number off? You need to go look. It takes a lot of man hours to get that right. Even then, let's say the person who created the AI process, they obviously had their context, their understanding. They knew when a number might be off and which edge cases to handle. If they leave the company, all of that IP, all of that context that they had with that AI is also lost. So it takes a lot of effort then to transfer that IP because the AI is so effective at automating, so effective at doing dynamic work. Explaining or handing over that IP becomes really difficult to future team members as well. So this all impacts the accuracy concern around using AI. The next concern here is then down to the cost side of things. Now, when we talk cost around AI, the cost is driven by tokens. When you buy a license, you get a certain amount of tokens included in that license, and it's typically a few million tokens. It sounds very big, but when you actually look at how those tokens are used, you notice that for every question you ask the AI, it can be a considerable amount of tokens used. Now, what drives that token usage? That token usage is driven by the context window. For the most part, the big part of it is how much context are you giving the AI to answer its question. As I mentioned at the start, the context could be the text, the level of text. So let's say you wrote a big question to it. Let's say you attached Word documents, Excels, you had a PDF, you gave it code. All of that is just all the raw text is a token cost usage, and then it needing to go and understand all of that. Maybe it needs to crunch data, maybe it needs to infer information, column names might not be clear to it, so it needs to think for itself, what does this column mean? All of that is token cost. And then as well, maybe you asked it for a specific type of output, like maybe just the text answer it gives you back, that is also token cost. Maybe it needs to convert its answer into Excel. It's obviously a bigger token cost. You see how all of these aspects of your interaction with the AI results in a bigger token cost. And this cost then is mostly driven by the input, but the output definitely has a big impact on that as well. So what is the risk around that cost? Let's say you are asking the AI a certain question about gross profit even or equipment utilization, something like that, but your whole team is doing the same thing, the same question or a variation of it, and this team member wants a filter on that subset. All of that adds up as token cost. Now each member has a license, but each member is basically using up their whole token usage cost, and that means um, a big overall actual cost to the company. You might have your AI running daily processes, these automations, these agentic processes where they compiling information quickly in the mornings for you. It's all very nice. It all comes at a cost as well. And now all of these costs, you might use up your token usage, but such a valuable process that now you allow licensing overruns and you start paying per token usage, pay as you go rates. These rates are typically higher than your actual licensing rates, but that process is so important, you are incurring the cost. And this typically happens maybe your context was so big, your cost was so high, your token usage was very high, so now you're automatically overrunning your licensing costs. Then another big consideration here, your AI needs to make an API call to places. A lot of platforms, they charge API rates in the licenses. So as soon as you need to make API calls, you typically have to buy a separate license. And now you're paying another cost there in terms of using API calls across platforms. Even with some third-party AI tools, you have to buy a license for making API calls to an AI as well. So there's another consideration there around cost. The last one here is automation cost. All of that is adding up to this automation cost, and a lot of companies are now on this route where they're saying, okay, we want to automate a lot of processes, but these are the types of costs that come into play, and you have to be very careful around how costly AI can become. And what part of our next discussions will be how to reduce this cost, how to make sure that we get the most bang for our buck when we're using AI. So to that point, definitely in summary, AI is very powerful. We use it a lot at Dataresti as well, but we have to keep in mind how to govern it. We have to always be aware what is the real context I need to give it? How do I get it to give me the right results? And we always have to be taking ownership of what is going on when that AI responds. And definitely the costs involved, we have to put into place a lot of tracking, a lot of control so that we manage those costs properly. So after on to the next point, yeah, is then the strategy. How do we go about making this more effective for us? Sorry about that. So on the governance side of things, we have to say, well, when we use AI, we use it for what is really relevant. In Dataracity, we consider AI to be really effective at innovation and at summarizing information for us. So really what we think the right approach is, yeah, we have to use AI for the innovation process. We would tell AI, listen, how do I automate this process? How do I build this report? AI will go off and very quickly give us answers. So the process of innovation is very quick, very fast iterations. But once we've got a result that we like, that we think is correct, all the assumptions were tested, we have to take that result and ask ourselves, how do we automate this? And this is a part where we say, well, we consider 90% of all tasks not requiring AI for automation. Power BI is a prime example. The AI might have a very nice report inside of its context window that looks really cool. The problem with that is every time you ask the AI to refresh, obviously the token cost is used, that refresh process runs, it needs to crunch new data, all of what we discussed is a problem there. And then your costs increase for AI usage. Whereas if you built a Power BI dashboard, it's automatically refreshed with data. You're not paying for the token usage of the AI. That's an example of automation. The same with maybe the AI built the Python notebook. If you ask the AI to execute the Python notebook every morning, you're incurring the token usage cost. Rather have the Python notebook go to a platform like Microsoft Fabric or Microsoft Azure or any of the scheduling platforms, and it can run that Python notebook for you. And in that way, you aren't paying the token usage cost daily. This automation step, it could even be that you have to maybe download emails. All of these types of steps, they are tools available that interact with these platforms. The AI just helped us understand which tools to use, how to use those tools. In that way, with us automating it, with the human in there building it out and saying, how did we get here? The human went through the business rules, the assumptions, the human understood what was needed, and it got documented as well. So there we're talking about building up the knowledge, building up that IP so that it's not all in the AI process itself. And that's how the teams own the logic. It's very important that that documentation exists for teams in the future, even if your automation steps still needed AI in it. There are places where that dynamic interaction is required, as almost always human related. Let's say you're asking someone to capture new information, the AI will step the users through how to capture that, and then that is where AI shines, is the dynamic side of it. And that's a very small subset of these automation steps. Everything else then gets offloaded into real automation. Now, this whole design, what we described here, we call it human in the loop. We consider it the best way to do any process with AI. And we've also mentioned that you have to take ownership. The human has to sit and decide. So almost any process that AI is involved in, it shouldn't be allowed to just continue and finish. There should always be a stop and say the human needs to step in, understand what happened, and say, yes, this is correct, or no, we need to go back and fix it. So the human in the loop design is really how we approach AI in organizations. To that point, and just to summarize all of that, AI does 80% of the work. AI is very effective at breaking the ice, at starting the innovation loop. Often we might sit and we might think, should I, shouldn't I? And you quickly fire off a question and it gets the brain going. It gets us working properly, innovating, finding processes that work. And that's 80% of the work. But that brings us to the other 20% of the work where the human is responsible. Now, that process takes longer, but it pays off in the long run where we are taking ownership. All of our business is understood, all of our decision making is accurate, and we don't lose any of the IP. So we say that 80% of the work is the AI, 20% of the work is driven by the user. So all of the things considered, then how do we enable this process? How do we go forward with helping businesses implement their AI? So we definitely have to start from the user. AI has different use cases. Some AI is good at some aspects, others at other aspects. We want to make sure users have access to all of those tools. What we therefore consider is that we should give the user a controlled environment, and we call it the sandbox. And this sandbox is definitely not on their local accounts. They need to be forced to use their private accounts, apologies, their enterprise accounts. There are ways to make sure no local accounts can access enterprise resources. It's always web-based, so you have firewalls in place, you have allow lists. So you definitely need to lock down your environment so that no personal AI tools are being used, all enterprise license based. That also ensures that all of those context stays within the enterprise, all of the chats are right there. When documents are loaded, it stays within the enterprise walls, which is very important. Now, when we talk about the sandbox side of things, this would be managed by an IT team. It would be made available to people who request it, and business users typically request it when they want to say, oh, I think I can automate something, I want to test out my example. What they would do then is they would go and talk to admin team, say, I want to try this. I need this data. I need this access to this tool. I need maybe some type of development process. And the admin team will then go and assign these things and make sure that only a subset of it is accessible. It's very important that that process is in place so that there's oversight, so that somebody who knows security risks is playing a role in making sure that should the user do their tests, that AI is only accessing what it's allowed to access. And then the user will go and iterate and do its thing, and the user will realize it's reached an answer. It has a process the user understands, and all the decision making is relevant. But still, no data was left in the environment. No data reached people it wasn't supposed to. That user didn't see personal information. That user's data didn't leave the GDPR boundaries. All of that is ensured and governed by the sandbox usage. And when we talk about the governance, we're talking about permitted sources. Is it allowed to see the emails? Is it allowed to see the SharePoint drives? Which folders in OneDrive can it see? Sensitivity tiers is controlled. There are manual steps where you might upload certain information and you made sure certain columns aren't in there. You made sure it wasn't payroll data. There's ways of managing this in your data landscape as well, where you assign sensitivity tiers, and the AI would then adhere to those tiers as well. Authorized connectors here, what type of things can it automate? What type of platforms, what type of websites is it even allowed to access the web? Is it allowed to only look at certain websites? All of that needs to be governed and set up by an admin team that manage this. And the big thing here is AI needs to be applied selectively. This comes back down to saying, well, most processes do not need AI to be automated for it. In that way, we reduce the exposure AI might have, and it talks to your credential sharing, talks to all those processes. If it doesn't need to use AI for it, we shouldn't use AI for it, just to prevent unforeseen risks. And then the big thing with the sandbox is audit the environment, make sure you know what the person was doing, make sure you could see what data was used, what queries they run. It also helps them to know how to automate the processes further. So this then is the starting point, the sandbox, the governance is at play. Now, this governance that we're discussing here is also at play overall, and we'll get into that a bit soon. So the first step to understanding how to effectively manage AI, do we integrate it in the company? The sandbox is part of this, but at Dataracity, we consider the central platform to be important. And we'll be going next into depth in the central platform. But the main point of the central platform, as soon as we centralize, and we do it in the BI world as well, we try and centralize it. Then we have a central data model. We centralize the business rules. We centralize all of the different steps in one area. That prevents the code sprawl, that prevents the object sprawl, that prevents the duplicated reports. So that centralized idea plays a role with the AI as well. And when we talk a central platform for AI and the way businesses use AI, you typically are automating business processes. You're typically trying to make business processes more accessible, more understandable. You don't want these different automations in different areas, different websites, different platforms, portals in the company. You want it all centralized in one platform. The benefit is that the user, when they land on this platform, they can immediately see all of the processes available. They don't think to themselves, oh, I don't see this process. We need to build it from scratch. So the centralizing idea is always really effective for us as well. We have the user will see what workflows there are. It helps with IP handover. They'll see what governance. It's easier to govern as soon as you have a central platform. It's easier to audit. You see who's using various options. You're seeing who's looking at various KPI definitions. And it also allows you to build automations. Yeah, we're listing Power Automate, AI assisted, Azure Foundry is a thing as well. You can see what schedules kick off. So it's really effective. As soon as you have the central portal, all of your business is there. You don't have to go dig for information. And what we are highlighting here also is that you have a single source of truth driving this platform, driving the AI. All AI would access the single cleaned data set, for instance. We use Microsoft Fabric warehouses and lakehouses. It's very well integrated, but it's all controlled, it's all cleaned, it's all managed, it's all accurate, and it's all structured in such a way that the AI can more easily use it. Now, that central idea that shared with a central data set and cleaned up, that data set is structured in such a way to reduce the context. So if the AI asks a question of that data set, it quickly gets answers. It doesn't need to infer a lot. It doesn't need to use whole data sets. It doesn't need to scan through many files necessarily. All of that ideas there, or even the business logic is clear to it. It can more accurately provide. So we're reducing the size, the context size needed for AI to provide answers. We're making sure the numbers it looks at is 100% accurate as well. So that central data set that's driving the central platform, definitely very useful, definitely very important way to approach implementing AI. Now, when we talk about how do we get things onto the central platform, how do we go from the sandbox to production, we always prefer there to be some type of approval process, some type of red tape in place when it comes to this. The business user does their innovation, they prove the concept, but their process might not be very clean, might not be very well structured, maybe not very effective or efficient. So then you need someone in the know to go officially productionalize it. And that makes sure that what you productionalize is very effective in the long run. All the edge cases are handled. Now, this process that we're showing here is a concept of how this cycle usually works. The users would go to the sandbox and they would prove their thing. And then they would say, okay, I'm happy. Now, what do we highlight here is what we call an AI champion. The AI champion is somebody who understands the business. They understand most of the rules in the business. They understand how things work, what assumptions are being made within the business. but they also understand how AI works effectively. So they're very knowledgeable as a super user. They're using AI. They know which types of prompts to use. They know when to be careful with various answers. And they're marrying their understanding of AI to the business as well. So that's an AI champion. They are necessary because they will take the um, proof of concept from the business user. They will understand, was it correct? They'll say, yes, I give my sign off. And then that concept can be moved to be productionalized. So that just means that whatever is given to the IT team to automate, to implement, is correct and it's clear. And you can think of the AI champion as a business analyst as well. And that just makes sure that what the IT team does is aligned with business. Now, we make reference on this diagram to a wish list platform. This is just a way to highlight to drive engagement with business users. Business users would see their proof of concept on the wish list, and it's a way to keep track what is busy being automated. We consider as a part of a good data strategy, as part of a good AI strategy, is engagement with business. How do we keep business very engaged with us? And we consider this wish list platform to be very effective because you can see, oh, my wish list is there. You can then also see it's being worked on. You can see comments on it, who likes it, maybe a voting. It really drives engagement, really makes it clear to business user what is being automated internally. And with more engagement, you're driving more thought process, you're driving more innovation, definitely useful in a data strategy. So IT would then go off and build it. Typically, you find ticketing systems inside of these environments. This is just like Jira or a process like that to make sure IT is documenting what are they doing. Very important, definitely best practice to have your tickets there, link it to the code, and you're capturing decisions made, you're capturing sign off, you're capturing everything that's required. Because in the long run, when you look back a year in the future and you ask yourself, why did we do it this way? Why is the AI doing this? The best place to go look is the ticket, the code that was committed, because it is supposed to show you all the decisions. Maybe you ran into certain limitations and you had to fix those limitations. The place to have documented that type of information, we consider it best to be in the ticketing system. So from there, then when the IT implements it, it gets implemented as maybe a process on the central platform. You can think of it as an app. Maybe this process is capture invoices. IT would have built this app, would have surfaced it on the central platform, and then a user would go into this app and they would say, oh, I need to capture invoice. They'll go to the central platform. They'll see the app capture invoice, and the app will then step them through. Maybe the first step is an AI interface where the AI asks them questions, and then the AI goes off and automates the rest of it. This is where Azure Foundry would play a role, or any other process tool. The AI would basically go and call certain steps. And again, those steps are doing the work, not the AI itself. And that's also limiting your token exposure. Maybe you're not using maybe it's a very straightforward. You want to do a lookup. That might be maybe a Power BI dashboard or something similar. You don't even need the AI to engage with immediately, but that process is on the central platform. Now, again, a big benefit of these types of platforms is system integration. Often you would have a business process that actually integrates with many systems. You might have your CRM tool, you might have your ERP tool, you might have your HR system, and one process that you're busy with actually needs information from all three. And in the data world, the integration concern is very big because you might have similar entities across all these platforms, but because of manual inputs, they somehow differ. And keeping data aligned between these platforms is a big integration problem. Having the central platform, having this business process automated, and having the centralized data set that we spoke of supporting this process means you've got a central set of information that you can make sure spreads to your other systems. And it keeps data aligned, it keeps information clean. There used to be, and it's still around as well. Microsoft called it master data management. That's the concept at play here as well. It's even more important now with AI, so that AI understands the exact same information across all three platforms. It can match it easily. It can match it cleanly. It uses less tokens to get its answers. And then the business users will, in the end, have all their knowledge supported on the central platform. Now, what's not shown in this platform here, in this diagram, is the concept of a knowledge base for the AI. And we've touched on it a few times. We've mentioned how AI needs business knowledge to understand what you're asking. There's a lot of work being done in this space now. How do we capture that business knowledge in such a way that is useful for AI? And this is where the knowledge base comes in. Now that central platform, we have the centralized data set. That's definitely one way of sharing business knowledge with the AI. We could also capture that business knowledge in various types of databases. It's very important, though, that that knowledge is captured. What types of decisions are users making? Yearly processes, what happens at month end? It's basically users documenting their daily process in such a way that the AI understands it. The long-term effect is that if you didn't have this knowledge base, AI would have to go infer all of that information. Every prompt you give the AI, you would have to retell it, how does this process work? Let's say a new business user comes in, they don't realize all the complexities around the process. The question they ask the AI, very little context provided. The answer they get, very incorrect, very vague. They would have had to then build up their knowledge and then ask the AI properly. This is an example of where the knowledge base would help a lot. The AI would go and say, I need to understand, how does utilization work? It understands your business. These types of questions differ per industry, and it even differs per company in that industry. So the AI would go and understand all of the edge cases, all of the complexities around the question, and that will also then inform the AI how to get to its answer. Now, again, it might need to say, oh, I need to go look at this data. It might need to go look at contracts. It might need to understand all of those touch points. But the knowledge base is telling it to do that. Obviously, this supports long-term IP handover as well. New business users can easily ask questions of the AI using the database, and it will then give them good answers. So they can explore how business processes works more easily. So the more information is captured as business process, as a knowledge base for AI, the more easily this knowledge is accessible to other users, the better and more accurate your answers are. So we kind of covered the central platform, we've covered the sandbox, the governance. All of this combined means that ideally we have less sprawl, we have less concern about duplication. Everything is more centralized, more governed. That centralization, the cleaning of the context, making sure the joins are very unique, making sure the data is accurate, there's no duplicates, all of these considerations means it's smaller context. The knowledge base also makes sure the AI needs to have a smaller context, automating many steps, also a smaller context that the AI needs. All of this is fewer tokens required to run your daily process AI. It means we're getting more predictable cost. We're getting a more bang for our buck. We're making sure that we can use AI for a lot more advanced things and worry less that we are burning tokens on the smaller processes. And that brings us to the end of the presentation. Thank you very Thank you very much for watching to the end. Let us know any comments you might have, any questions you might have. We'll be happy to answer them.